Hey, my friend Arthur Moore is here. Hope all is well. In this video, we're going to look at exponential functions, differentiation, and integration. So, just some basic algebra functions we have here. We know that the natural log of e to the x is equal to x, and e raised to the natural log of x is equal to x. They have an inverse relationship, the e to the x and the natural log of x, as you can see in the graph there. All right, so this first theorem that we're going to look at is for the derivatives of natural exponential function of the natural exponential function. It said let u be a differentiable function of x. Then d dx of e to the x power is simply e to the x, or d dx of e to the u is equal to e to the u du over dx, or e to the u du. All right, so first of all, let's go back and look at a few of the algebra functions here. It says solve for x accurate to 3 decimal places. Well, e to the natural log of x, those are inverses of each other, so that simply equals is x to the or equals 4. So those are inverses, so they cancel each other out, and that brings that x down. That makes x equals 4. So number two, e to the natural log of 3x equals 24. Again, the e and the natural log are inverses of each other, so that gives us 3x equals 24. Divide both sides by 3, and x equals 8. Okay, what about 9 minus 2 to the 2ex equals 7? So the first thing we want to do is to isolate the ex. So let's subtract 9 from both sides. Divide both sides by negative 2. Then to get that x out of that exponential area, we want to take the natural log of both sides of the equation, because the natural log of e to the x power is simply x. And in your calculator, the natural log of 1 is 0. Okay. All right. Number 10, we have 5,000 over 1 plus e to the 2x equals 2. So again, we want to isolate the e to the 2x. So the first thing we want to do is to get it out of our denominator. So I'm going to multiply both sides of the equation by 1 plus e to the 2x. All right, and then I see that I can divide both sides by 2, because again, my goal is to isolate the e to the 2x function first. So divide both sides by 2. And then subtract 1 from both sides. I'm going to flip this around, so I'm going to have the e to the 2x. If I subtract 1 from 2,500, that gives me 2499. And then again, we want to get that x out of the exponential location there, so I'm going to take the natural log of each side. That allows me to bring the 2x down, because the natural log and e are inverses. And then divide both sides by 2. So in the calculator, we will do the natural log of 2,499 divided by 2, and that should give us approximately 3.912. All right, let's look at the natural log of x squared equals 10. Now here, to get rid of the natural log, we want to bring in the e, and we would move that natural log of x squared into the exponential location, because before, remember that e to the natural log of x here equals x. So if I move this here like so and do the same thing on the opposite side of the equal sign, then that allows me to cancel out that natural log, and that leaves me with x squared equals e to the 10th. All right, so now if I take the square root of both sides, remember the square root, that's the same thing as dividing that 10 by 2, so that gives me x equals positive or negative e to the 5th. And then we throw that in our calculator, the e to the 5th, and that should give us approximately 148.413. Okay, so we just use those algebra rules to manipulate the e and the natural log, knowing that they are inverses of each other. Okay, let's look at the derivative. So again, we said that our derivative, if we scroll back up here a little bit, derivative of e to the u is equal to e to the u du dx. Now, if it's just e to the x, then the derivative is e to the x. All right. This is e to the 2x. So let's let u equal 2x. Therefore, du dx equals 2. All right. So our derivative is e to the u, so it's e to the 2x du over dx, which is 2. So f prime of x equals 2e to the 2x. Okay, and before, and so we won't confuse you, before we just said that du was equal to 2 dx. So all we've done is divided both sides by dx, because our formula said that the derivative of that e to the u is e to the u du over dx. So that's why we just have that 2 there, like that. So again, look at the formula here. The formula said that it's equal to e to the u du over dx. All right, so number 35, let's let u equal the square root of x, and if we're going to find the derivative, we need to rewrite that as x to the 1/2. So du is equal to 1/2 x to the negative 1/2 dx. So du over dx is equal to 1/2 to the x to the negative 1/2. Okay. And we could really rewrite that a little bit, but we can clean it. I guess we'll clean it up. Well, let's just go ahead and rewrite it. So that's 1 over 2 times the square root of x. So I have the 2 in my denominator from the 1/2, and the negative 1/2, I just move that down to make that exponent positive. Okay. So now I have y prime equals e to the u, so e to the square root of x, times du over dx, which is 1 over 2 times the square root of x. So e to the square root of x over 2 times the square root of x. Okay. About number 43 here, we have g of t equals e to the negative t plus e to the t power of t all raised to the third power. So to find our derivative, we know we'll have to use the chain rule. So we have 3 times e to the negative t plus e to the t raised to the second power. And then we have to use the chain rule. It means we have to multiply times the derivative of the inside of that function. So e to the negative t, we know the derivative of e to the t is simply e to the t based on our rule. But what about e to the negative t? Let's look at u du and see what we come up with. So if we let u equal negative t, then du over dx equals -1. Okay, so the derivative says that it will be e to the u d of du times du over dx. So e to the u will be e to the negative t times du over dx times -1. So that would just become e to the negative t times -1. And we know the derivative of e to the t is e to the t based on our theorem. So the only thing that would change here between those two is that if we have e to the negative t, then that will become negative e. The derivative of that will be negative e to the negative t. So g prime of 3 times e to the negative t plus e to the t raised to the second power times negative e to the negative t plus e to the t. I left myself enough room to work this other problem out over here. Okay, so we just use the chain rule on that one. All right, what about number 47? We have y equals 2 over e to the x plus e to the negative x. So what rule do we need to use to find that derivative? Right, the quotient rule. So we have low d high minus high d low over low low. Okay, so y prime low e to the x plus e to the negative x. Derivative of any constant, so derivative of 2 is 0 plus high, so 2 times the derivative of our denominator. So the derivative of e to the x is e to the x. Derivative of e to the negative x is negative e to the negative x, just like we found over here with problem number 43. All over our denominator squared, low, low. Okay, so let's clean this up some. That should be minus there. Low d high minus high d low. All right, so let's clean this up a little bit. So we know 0 times anything is 0, so this goes away. So that's 0. So we have y prime equals -2 times e to the x minus e to the negative x all over e to the x plus e to the negative x squared. Okay. What about integration? Integration rules for exponential functions. Let u be a differentiable function of x. The integration of e to the x dx is equal to e to the x plus c, or the integration of e to the u du is equal to e to the u plus c. All right, so the first thing that we want to try to do when we have these the e with the powers, we want to see if we can let u equal to that exponent and see if the other part of the function that's remaining gives us some form of du, or see if we can get some form of du out of that. So here, if we let u equal 5x, then du equals 5 dx. So there we have it. You see, this is u, then this part is du. So that gives us the e to the u du. So we have the integral of e to the u. I'm sorry, why I'm not sure why that keeps doing that. Let's see here. That gives us the integral of e to the u, and then 5 dx is du, which is the same thing as number 2 in our theorem here. So that integrates to e to the u plus c, and then we replace that u, of course, with 5x, write it back in terms of x, and there we go. So again, once we see that e, if we can let u equal that exponent and get some form of du to equal the remainder part of that function, then we'll use this theorem above. So number 93, let's let u equal 2x minus 1 and see if we can get some form of du to equal dx. So du equals 2 dx. So we see we can divide both sides by 2 or multiply both sides by 1/2 and gives us 1/2 du equals dx. Okay, so 1/2 of du equals dx. All right, so now we have the integral of e to the u, and then dx is equal to 1/2 of du. So we would pull the 1/2 out in front. And we know the integral of e to the u du is e to the u plus c. And we know that u is equal to 2x minus 1. Okay, let's look at another one. All right, number 97, we have e to the square root of x over the square root of x. So again, let's write this in exponential form and let's see what we can come up with. All right, so if just a second here. So let's e to the x to the 1/2. So if I can let u equal x to the 1/2 and get some form of du to equal 1 over x to the 1/2 times dx, then I can use the theorem above. So let's try that. So let's let u equal 1/2 or x to the 1/2, and which is the exponent on the e, and then du would equal 1/2 of x to the negative 1/2 dx, and that x to the negative 1/2 is the same thing as 1 over x to the 1/2. So let's go back down here and move this x to the 1/2 up and change the sign of that exponent like so. So now the only thing I need to do is multiply both sides by 2 to move that 1/2 from over here to the other side of du. So 2 du equals x to the negative 1/2 dx, which is the other part of that x to the negative 1/2 dx. All right, so let's write out what we have back here in the integration. So we have e to the u times x to the negative 1/2 dx is equal to 2 du. Okay, so that allows us to bring that 2 in front of the integration symbol. And then we know the integral of e to the u du is e to the u plus c. And then we know that u is equal to x to the 1/2 power. And since this started off with the square root, I would probably write it back with the square root form. So e to the square root of x plus c. 2 times e to the square root of x plus c. Okay. How about number 99? This will be the last one that we look at here. Okay. Let's may need a little bit more room, so let's just curve this over here. Okay, so we have the integral of e to the negative x over 1 plus e to the negative x dx. Well, if I let u equal negative x, then du equals negative 1 dx, which we could not get a form out of this 1 plus e to the negative x out of that. So that would not work. All right, so next plan, we still are going to try to use the u du substitution, but let's let u equal the more complex part of this function. Let's let u equal 1 plus e to the negative x and see if we can get something out of that. So u equals 1 plus e to the negative x. Then du equals, so derivative of 1 is 0. Our derivative of e to the negative x is negative e to the negative x dx. And what we needed was e to the negative x dx. So let's multiply both sides by negative 1. So negative du equals e to the negative x dx. Okay, so now I can rewrite my integration in terms of u. All right, so we have 1 over u, and e to the negative x dx is negative du, so times negative du. So remember, so I understood 1 up there, and then we let u equal 1 plus e to the negative x, so that's where the 1 over u came from, and then times e to the negative x dx, which was equal to negative du. Okay, let's pull the negative out in front, and we just looked, recently we just looked at this integral of 1 over u du, and we said that the integral of 1 over u du is equal to the natural log of u, of the absolute value of u, plus c. Okay, so negative times the natural log of the absolute value of u plus c is the integration of that, 1 over u du. And then u, let's replace u and write this back in terms of x. So 1 plus e to the negative x, and then plus c. Alrighty, good people. Alrighty, my friend. Hope you found this to be helpful, and I will see you on the next one. Thank you.